going to be working on changing standard form into vertex form. So, up to this point, we've seen these three types of formulas for a quadratic equation. The first is considered standard form, the second is known as our vertex form, and the third is our factored form. Now, these equations can all represent the exact same parabola, just in different forms. So, first of all, one of the things we learned was how to change vertex to standard form and how to change factored to standard form. Anyone remember how to change factored to standard or vertex to standard?
You r plus s divided by 2.
No, you're thinking of finding the vertex. How do I change a factored form into a standard form? It was the first thing we did in chapter 5.
You had to divide a, like
Oh, I don't remember. Anyone remember? It starts with the E, 2 words. E and S.
No.
No. Okay. You need to expand and simplify to change those. Okay, so you needed to expand and simplify in order to change either vertex to standard form or factored to standard form. Now, to change standard to factored form, we did this all of chapter 5. A method. What was it called? Changing standard to factored form. We spent a whole chapter on this. Starts with an F. Factoring, excellent. So you're factoring to do that. So we said that changing standard to factor form, we worked on it, and it's called factoring. Great. So, of the 4 movements, we know 3 of them. The last one we're going to be working on today is changing standard into vertex form. This is called completing the square. Now, this is a lengthy process. Completing the square. Okay. Now, this is not an easy process, so I need you guys to pay attention as we go through this. I said I did a harder example earlier today. We're going to work on a simpler example. Still going through the same process. Let's say we have y is equal to x squared plus, minus 10x plus 5. This is just an example. First of all, what form are we in? Standard, excellent. And the goal is to get it into a vertex form, mainly probably because we want to find the vertex, either a maximum or a minimum. Okay? So, in order to do this process, the first thing we need to do is discover what the A value is. What is the A value here? Good. That A value is very important. We take the A value and we divide the first 2 terms in the question by the A value. Now, like I said, this is an easier question. Because it's divided by 1, is that going to really change anything? No. Okay. I still want you to get used to this process. The 1 would come to the outside, or whatever A value it is, and we'd be left with what's inside. So we have x squared minus 10x plus 5. Okay. Now, the next part of this is a formula, and we'll do a little side calculating here. The formula goes like this. Our b value divided by 2 squared. Okay. So, what is our b value right now in the second step of this? Negative 10. Now, this b value, in some cases, will have changed from the beginning. If a was a different term, say it was 20 and we divided by 2, it would have then been 10, something like that. Okay. We always take the newest b value, what's in the brackets. So in this case, we have negative 10. So we plug negative 10 in. Negative 10 divided by 2 is what?
Negative 5.
Negative 5. What's negative 5 squared?
25.
Just 25, right? Now, 25 is very important. We're going to add and subtract 25 inside of these brackets. If I add and subtract 25, what's the equivalent of putting into equation? 0. So essentially, we're not changing the equation. We're adding a 0 to it. But the reason we're doing this is because we're trying to create a perfect square trinomial. So our next line reads y is equal to, we can still keep the 1, x squared minus 10x. And we're going to add 25 and subtract 25 inside those brackets. Again, that's like just putting a 0 plus 5. Now, we don't want the negative value to actually be inside. We're going to take it to the outside of the brackets. But in order to take it to the outside of the brackets, we have to deal with bend match. And in that case, we have to use distributive property. This 1 in front must be distributed to all 4 of these. So if I'm taking negative 25 out, I have to make sure to multiply by my a value. What is the a value here? 1. Yeah, so in this case, again, it doesn't change because this is an easier example. Okay? So, what we've just done there, we have y is now equal to 1. X squared minus 10x. We keep the positive value, 25 inside. The negative value times 1 is still negative 25. And then plus 5. So we've taken the 25 to the outside of the bracket. So, the reason we have done this is we now have a trinomial inside. And this is actually known as a perfect square trinomial. Perfect square trinomial is something that when we factor it, the 2 brackets end up being the same values. So we can represent it as a bracket squared, which is exactly what our vertex form deals with. A bracket that is squared. Okay, we're trying to create that. Now I can factor this normally, and I can show you the shortcut. So I'm going to quickly factor this normally. And when we factor this normally, what are the factors of x squared? Yeah, 1x and 1x. Factors of 25? 5 and 5 and 1 and 25. We need the 2 terms to add up to what? Negative 10. So what do we use? Yeah, negative 5 and negative 5. Okay. So our brackets are going to read x minus 5 and x minus 5. Now instead of actually going through the factoring, which I know you all remember this way, a quicker or another way to do this is to take the first term and the last term and find the square roots of them. Okay? So if we find the square roots of the first and last terms, in this case being x squared, so square root x squared, what is it? And the last term, 25, let's square root 25, 5. Those are going to be the 2 values in our 1 bracket. So we're going to have y is equal to 1. And in our 1 bracket, we have x as the first term, 5 as the second term. And we know the bracket must be squared. And what we do from there is we take the operation. So this operation here, and we bring it down. Is that positive or negative? Negative. So we bring the negative into this. You can go about factoring it, that's fine, but this is the shortcut. You square root the first, last term, and take the operation of the middle term. And finally, negative 25 plus 5 is negative 20. So our vertex form, just to rewrite it,
How come you didn't write it twice? So why don't you just...
we don't need to represent it twice, because they're identical.
If they were...
So, that's the process of completing the square. We've gone from standard, okay, our standard form here, and our answer is in vertex form. Still the exact same equation, but we're able to find the vertex quite easily. Okay?